Hello again folks. In tonight's short video I'm going to be conducting a little experiment using this super cheapo DT-830B Multimeter, which you can get pretty much anywhere online for a couple of pounds including delivery, you know, a few dollars. And essentially what I'm going to do in this experiment is attempt to overload the current input. The meter itself is rated to 10 amps DC. I should mention at this point, unfortunately, I don't have a load capable of generating 10 amps or above, a DC load that is. So I will be using an AC load in the form of a 3 kilowatt fan heater. Fundamentally, AC and DC current are different, I appreciate that, but I don't think it will have that big an impact on the end result. I think it'll be a fairly similar result regardless whether it's DC or AC. Ultimately, we're going to be pumping around, well, let's do some basic maths, 3000 divided by 245, which is the average UK voltage in a domestic supply here. I think a tad over 12 amps, something like that. So yeah, ultimately we're putting over 12 amps through this piece of equipment. So how we're going to do it? Well, I've cobbled together this in a Heath Robinson fashion, this connection method, just a chalk block connector. We've got the earth and neutrals just common together, and I've split off the live, the hot side, and it's going through the multimeter. Simple as that. We've got AC input here and our AC output here. And all I'm going to do is basically plug the input into the main supply, as you would expect. Turn this over and plug in the fan heater and see what happens to the circuitry inside. So just have a quick look on the other side. You may recall from my previous videos, this has no input protection whatsoever. We've got a common going straight onto the track here, and the current input here on this top connector. And that's again just going to the track there. We've got this 10 amp current shunt here as well. So how's it going to fail? Well, I would imagine that these tracks or traces, whatever you want to call them, will probably just blow off the board. Either that or it will generate a lot of heat. Now, if, for instance, the 12 amp load from the fan heater isn't enough, I've got another option where I can add in a little bit more of a load. It's probably going to push over 13 amps, so I'll just need to be a little bit careful with that, but we might not need that. So I think now we'll just go ahead and give it a go. So let's get this set up. I'll take this to one side and plug in the input. So there we go. So that is it now live. I'll just try and get that there. Now I do have my little Raytech mini temp here, so I'll just take us at a reference temperature reading. So the current shunt somewhere around 19 or 20 degrees Celsius, or centigrade if you prefer, exactly the same thing. So yeah, just under 20 degrees Celsius. Right, we will plug in our load now. Where is the plug for that? That might help. Here we go. And that's it plugged in. And nothing has went bang, which is a little bit disappointing. Let's just get our thermometer in again, and as you can see the heat is rising on this. Maybe a slight bit of discoloration on this input terminal here, quite hard to tell. But yeah, we're up somewhere, difficult to get an accurate reading on this, but somewhere around 50-60 degrees. So I'll give it a few seconds just to see if anything actually happens. So yeah, again up to 60, sort of 70 degrees there. But no catastrophic failure. But yeah, I can definitely smell it though. And the leads, as you can imagine, are heating up very slightly. Okay, right. What we'll do now is we will bring in an additional bit of load. I've got another heater which is capable of delivering 1250 watts or 750 watts. So 750 watts is probably the most suitable to add in at this point. Like I say, it's going to take a couple of amps over the fuse rating and the you know, the mains plug, so it might pop the fuse before it does anything else. So we'll give it a go now. We'll switch on the 750 watt load in addition to the fan heater, and again we'll see what happens. So 3, 2, 1. Okay, nothing. Slightly disappointing yet again. Let's quickly measure this, see if it's made any difference. One would assume it will. Right, I'm getting a bit of smoke now. That shunts up to 100 degrees pretty much. The solder has started to melt on that lower, the right hand side connection as you see it there. Bit of burning, nothing else. As you can hear, the fan heater is still kicking out the good stuff, but you can see now that is massively discolouring. We've got smoke coming off the inputs. Let me just lift these leads up, make sure they're not melting onto my ESD mat. Okay, still nothing catastrophic. So I think at this point I will switch off the 750 watt load and then plug in an additional 1250 watts. So let's give that a go. I imagine it will just pop the fuse now. No, it's not. But I don't know how well that's coming out. The common connection is glowing bright orange now, and the leads are totally melting. So I think at this point we will end the experiment. As you can probably hear the urgency in my voice, I'm going to lift that up. I'm going to disconnect the mains, and we'll have a quick look at the end result. So bear with me one moment just to disconnect this. Okay, welcome back. Right, okay, let's have a look if I can get it to focus. There we go. Nothing actually failed on the board. There was a lot of heat, as you can see. It's totally distorted this input here, the common input, and it started to sort of lift off the board. There we go. The trace is still intact, as you can see. Just a lot of heat damage and a bit of crustiness formed on there. Yeah, the actual current input, nothing on there at all, just on this common side. Shunt is still a little bit hot, and obviously the plastic has melted and deformed. And of course, let's have a look at the leads. The common input, which is the one that was generating the most heat there, is pretty much unscathed. No problems at all with that, really. However, the supplied leads, as you can see, let's have a look here. Yeah, not so good. 1000 volts, we don't have a current rating on these at all. Ultimately, they are super cheapo leads, very thin. In fact, let's cut it in half and see what it looks like inside. Yeah, not a lot to it. Focus. Yeah, I don't know how many conductors are in there, maybe 15 or 20, but not a lot at all. Probably about 0.5 millimeter cross section on that, something of that order. But yeah, totally destroyed the leads, and luckily didn't destroy my mat too much. Just a little bit of rubber on there, as you can see. But there we have it. Yeah, not particularly scientific or any sort of method in it. I just wanted to see how safe this cheap meter was if you were putting a massive load on it. I suppose you can argue that it is fairly safe for normal stuff. I mean, we did have quite a large load on there initially, and other than, you know, getting slightly warm initially, it wasn't too bad. Clearly, when we put on, I think we were up to something like 4.25 kilowatts. That's when the lead started to melt, and you know, there was a lot of heat generated. Clearly, you don't want to be measuring high currents for any great length of time on this, if at all. Like I say, pretty much you're going to want to get a slightly better meter, something like the VC97, or more recently, as I've been talking about, the Aneng here, the AN8001. These do have, you know, they are fused inputs. They're going to be safe. Any sort of load of that sort of value, the fuse is going to pop, your meter's going to be safe, and hopefully you'll be safe as well, in terms of your meter's not going to burst into flames. But there we go, little bit of fun, I suppose. If you enjoyed the video, give me a thumbs up. If you didn't, give me the thumbs down. That's pretty much it, guys. Thanks for watching. As always, take care of yourselves. Until next time, all the best.